Hi, my name is Noah Gift, and what I'm going to talk about today is how to be successful on the first day of work as a data scientist, as a business analyst, as a business intelligence person. What are some of the things you can do to immediately make an impact within, let's say, a couple hours, have an environment set up, and then go through and do whatever you need to do an initial analysis. So use let's say no code, low code tools to do natural language processing or computer vision, how to use a little bit of data science, maybe ingest some code, create reproducible notebooks. So in general, if you just started as a business intelligence person at a company or a data scientist or a data analyst position, this is a great feedback loop for you to get started. And let's go ahead and proceed.
Why is it you want to tell a story with data? How do you do it? What are the different processes involved? And I think this repo right here is a very good one, this data storytelling repo. And I'll also show you, what I would recommend if you're working at a new organization or you want to create a portfolio project, is I would create something like this. And let's start to build this together. And let me show you how to build this repo that can be the center of what you're doing. So let's first though draw this out, and let me just take in here what it is that we're going to build. So inside of this location, we're going to have a GitHub repo, and this is often a pretty good location to keep all of your assets, especially if you're going to give other people a link to your portfolio. So you want to show them the kind of work you can do, or you want to give this to, let's say, the CEO or some other executive. And what are we going to put inside of here? A lot of times you can put a notebook, which we'll build in a second. And then also what you can build inside of here is the data itself. And so in many cases, you can put a little bit of data inside of a GitHub repo, and this can really be the kind of the center of the universe for the project that you're building. So let's go ahead and start out with building a GitHub repo from scratch. So in order to do that, I'll show you a couple neat little tricks here. So one is we can say new, and we'll call this data viz, and then I'll put in here, this is a new portfolio project. And what I would recommend when you're creating a new repository, especially if you're new to GitHub, I think many students in data science and business analytics have really not done a lot of coding. And so this is something that you may not have had experience with, but when you first create a new repository, what I would recommend is I would put a description here. I would add a README file. And this README file is something that will complete and add more metadata about, so that people can find your work and know exactly what it is. This is another one that's really important, is to add a gitignore file. And if we go here, they have a template of different files that we can ignore. And the reason why you want to do this is that later when you're checking in different scripts or parts of your Python project, you won't have to worry about checking in things that are really kind of garbage files. So files that don't add value to your project. And so this is really important to add. And then, later you could also choose whether you want to add a license. For now, we don't need to do this. Let's go ahead and create a repo. And once we've done this, we have this, initial project here. What's neat about it is that I can also start to edit this README file and put new things inside. So for example, I can do this. I can say, section, right? And notice that there's a hierarchy where this is larger and this is not as large, but let's say we'll call this, exploratory data analysis. And it's a good skill to have, to just be aware of how to edit these type of README files, because this is really the first spot. So if someone goes to my repo, they see that this is the information that I'm building. And one little trick that I'm going to show you that's pretty neat is that it's pretty easy to even add rich images inside of your project. So for example, what we can do is if we do this, it's kind of a hack that you can do to host free images, if we create a new issue in this issues tab and we call this issue images, what's kind of neat about this is that I could go to some place where I want to grab some data, and let's just grab this. Let's just take this screen cap right here, and I'm going to, I don't know, maybe just take a picture of this like this, and then I'm going to just save it to my desktop. And then now what I'm going to do is I'm going to go to this issue here, and I'm going to select attach files, and here we go. Here's the screenshot. And now all I need to do is just grab this, right? I don't need to do anything. It saves an image for me. And then if I go back to this location, I can say, this is an example of an image. And then I just throw it in there. And now if I save it, we've got image hosting. So a pretty neat little trick you can do that really adds a lot of, I think, polish to a GitHub project. And so you may want to, as you're building out a portfolio project, kind of get into here and change things around a little bit so that you're able to, really take advantage of this style where you can put, key images from your project or different things that you're working on. So now that I've got this set up, the next thing that I'll show you that's pretty neat is that if you have a student GitHub account, or if you have a professional GitHub account where I think you pay $10 a month, if you select this, there's something called code spaces. And this, in my opinion, is one of the best ways to work on a project is in a cloud-based development environment. And let me just briefly just talk about this. So in the future world, the way I see it, most people will be developing in a cloud-based shell. And so here we go. We can say cloud shell like this. And inside of this cloud shell, you could either use GitHub. That's one. So we can do this. You can also use AWS. That's another cloud shell. You can also use GCP. And you could also use Azure. So you can basically develop all of your code inside of a cloud-based shell environment. And I'm going to show you how this works. And then you don't have to worry about how powerful your laptop is, or whether even you have your laptop. You could go to the library, you could go to your friend's computer, and all of the work is done in a web browser. So I really think that this is the future of how a lot of people will be developing software, especially business analytics and data science. Like, why work hard when you can work smart? And I think this is one of the techniques. So if we go back here and I go to this code space, what'll happen is it'll ask me if I want to use an existing one or if I want to create a new one. I'm going to create a new one, and I'm going to go to this data viz repo, which is right here. And then I'm going to select which branch. So the way GitHub works is you can actually create multiple copies and different versions, almost like with Google Docs or Microsoft Word. You can create different versions of a document. The same thing applies with your code. You can have lots of different versions. In this case, I just have one branch, so I'll leave everything by default. But let's go ahead and go here and say create a code space. And then once you set up this code space, you could, if you wanted to, even use Visual Studio Code on your desktop and kind of communicate with it. But for my opinion, really, I think the majority of the use case that I prefer to actually just work right in the web browser. And look, you see the stuff that I just worked on. Notice that I can get a preview of it and actually immediately start, using this stuff. Now, if I wanted to actually edit it, I could also edit it as well. If I go here, I can go through and, figure out how to do that. But in a nutshell, the big thing, here we go. If I click on the README file, you can see I can edit the raw, the markdown file. But one of the things that I like to do when I first start working with a project here is I'll create a Python virtual environment. And this gives me the ability to protect things so that my code isn't going to have library conflicts, or, I don't have to worry about what was previously installed. And so in this environment, they have virtual environment already built in. So we can do this. So I could even put this in as instructions, like how to use a code space like this. And then I could go through here and I could just say tilde/.code. And now what this does is this says create a virtual environment, which again is just like a directory. Create a directory that's inside of my home directory and use this dot in front so that I don't have to see it. It's kind of hidden away. And this is actually important to be aware of with these virtual environments, is that you don't want to create one in your current GitHub project. And this is a common mistake that people make because it's really like a transitory artifact of what you're doing. You don't really want anything to do with the virtual environment outside of just using it to install your libraries that you use temporarily. So I'm going to go ahead and create this. There we go, virtual environment. And then once I do this, and I say source like this, you can see that I've got a Python that's available for me right here. So maybe even put this as a step. Say set up a virtual environment. So we just say, and when I can even put these commands in it. And this is kind of a neat thing to be aware of is Markdown. You can actually put code snippets in here. So if I go back to the preview and it's got a little preview editor here, notice that it will show me, look, that it's now made it into a code snippet. So I can basically kind of go back and forth here and see my changes in real time. So we say set up a virtual environment. The next thing that I think is a very good idea is set up a very small scaffolding so that you have a basic sane structure for all data science projects. And I think this is a good idea. So what I typically do is I create just a few files. I'll create a Makefile. I'll create a requirements file. And so I use these with the touch command, but you could also just go to the menu and say, I think you can just click on this file, file new, and you can make new files that way. I just find this to be even simpler, right? And then you can see that they show up right here. And then we could just make a basic file here like this, and then maybe like a test file, test hello. And the idea here is that this isn't more work for you as a Python programmer or data scientist. It's less work because you can create this level of automation that will test your project and even your Jupyter notebooks. You can actually test it. So let me just show you real quick what to put in here. What I typically do is I'm going to open up another project I have and just copy some things from it. If I go to PyTest here, GitHub Actions PyTest, I previously had some of this scaffolding. I'm just going to copy it, and you can click on the raw button here. If you want to copy somebody else's code in GitHub, this is a good way to do it, is go to raw, and then I can just copy this. I can just highlight it like this, copy it, and then go to this location, and I click on the Makefile right here. And notice that it opens up exactly the file. So it's a very good development environment. I just paste this like this. There we go, pip install, et cetera. It goes through and shows different steps. And so what a Makefile does is it's really like a formula that you would use where it's less work for you to type these commands in when you're working on a project. So if I want to install my software, I just say make install. If I want to test my software, I say make test. If I want to format my code, I could say make format. We'll take that out. We don't need that. If I want to lint my code, and what linting does is it checks for like syntax. So this is a very quick step, but in my opinion, a very recommended step for people when they're first getting started. And you only need to do it once on a project, and then you really don't have to worry about it again. And I'm going to show you why it's so valuable. So we've got this, right? We have install test lint. I'm going to go to the requirements here. This is where we would put what are the packages we're going to use. So I would say probably PyTest is one we want to use. Maybe even Jupyter. Maybe we want to use Jupyter. And then let's start with that. So if I do this and I say make install, and actually I think we want PyLint as well. So let's try that, PyLint. And what will happen is that this should install everything here. There we go. So we've got this installed. I'm going to do make install again so that I can also install the lint tool. There we go. And then really just to show you very, very quickly, like why this is a neat thing to be aware of, even for a data scientist or a business analytics person, is that I can really quickly test things. So we can say one, make a quick function, and I'll return one. And that's literally all I'm going to do. And then I'm going to make a test that says from hello, import one, and then I can say def test one, and all I do is I just say, look, does this value match what the function's returning? So I look at the function and I call it, and I say, does this equal one? Right? We saw that this is a very simple function. All it does is return the number one, and then I'm going to write a test for it. And to do that, I'm going to say make test, and this will run my test command, which if we go to the Makefile is this command. Like I could type this in. I could say python-m. It's just too much work. I would rather just do this, run make test. There you go. And we see it pass. Now, if I want to make it fail, I could just say assert the wrong value, right? Because we know it's returning one, not two. If I do this, we go through here and we see that it fails, right? So this is so simple to set up. Only takes a few minutes. I do this on all projects I work on. And it's really important too, if you're working with teams of people, that you get this basic level of continuous integration. So continuous integration is basically automatically being able to know that your project is successful. Notice that if I do a make lint, that it says everything is syntactically correct because it's only the logic is incorrect, right? Because we're asserting the wrong thing. But if I added some incorrect syntax, if I did this, if I added like a variable definition that's incorrect, and now I do make lint, look what happens. It says exactly the problem. It says that you have invalid syntax. So not only can you check for syntax errors, but you can also check for logic errors in your code. And so depending on what you're doing, I think is a very good initial step for any project. Now, the next thing, all we got to do is this. We have to just say git status and push these files into GitHub. And so I'll just say git add star, and that just says add everything in my project. And then if I want to do a git status again, you can see that it's going to stage all these to be committed. And so now I can do the commit. So I can say git commit -m, adding initial structure. And then I can say git push, and it should just let me push those files. There we go. And now if I go back to GitHub here, and I go to this latest repo that I just set up, which should be this, that you can see that all those files are here, right? We have even the README, we have these hello files, and by the way, it's broken, right? Because remember, it's got bad syntax and it's got a bad unit test. So one of the things that we can do, really the final step here to get the initial process set up, is to go to this thing called actions here and click on actions. And what's neat about actions is that it's a automatic continuous integration server that will work for your project. So for data science, I think this is very important because it's going to save you time. You can do other things if later you wanted to deploy code to the cloud, or do things with Terraform, or Tencent Cloud, or whatever it is you want to build. You can do all that. We're just going to do a very easy one. Set up a workflow. Click this button. It gives us like a sample project here, but I'm going to actually grab another one. I'm going to go back to that original PyTest thing I was working on, and I have a example that I'm going to copy. So again, I'm going to click on raw. I'm just going to copy this other GitHub Actions config. I'm going to paste this in, and I don't need the format. I'm just going to install my software. I'm going to lint it, and I'm going to test it. And notice that you can even pick which version of Python you want to work with. Now, we could even go back real quick to this location and see, okay, Python 3.8.6. Okay, great. So maybe let's test the same thing. So if I go here, maybe we can try that. Does it, Python 3.8, that's close enough. We can say start commit. And then what it'll do is it'll immediately start to do the build process for us, which is what we put inside of this configuration file. So we can see that it says, okay, it's building. And really all it's going to do is do those commands I did locally. It's going to install the software, it's going to lint it, and it's going to test it. Now, it's going to fail at the lint, I believe, first because it's got bad syntax. And so this also lets us see very quickly that there's a problem with our project, and so that allows us to then later fix it. This is really important, I think, especially with data science teams, is you can see whether the code you're working on works or not. I mean, it's almost impossible to work on a team that does data science if you don't have some basic level of quality control. So we can see here's a problem, right? And in fact, I could even click on this icon here, and there's something called a status badge. And I can copy this and then go back to my project, and in the README file, just so click here, I can just put this at the top, and this just lets anybody that's working on my project see whether the build is working or it doesn't work, right? So this is basically descriptive statistics, right? Fail, it's binary, right? Doesn't work. So we need to fix it. So let's go back to this code editor here, and let's do this. Let's say get pull like this, and then what we can do is I can say make a lint, and we know that it fails, right? Because it's got bad syntax. Let's fix that. So I'm gonna comment that out. I run make lint. There we go. We know that works. And remember that the test also fails. Make test. It's asserting the wrong thing. Let's go ahead and fix the test function to be a function that tests the right thing. We say make test. Now it works. Now all I got to do is say get status. Add those two things by doing get add star, doing get commit, adding two fixes, and there we go. And now my teammates are going to be happy because they can look at what happened and see, and they can even watch in real time. You every time you do a change to GitHub, it'll rerun those steps for you, and you can see exactly whether the code is working or it's not working. There's a lot of other things you can do with GitHub Actions. You can build containers. You could even use models and pull ML models. You could push it to the cloud. But in general, for this, I would call this, this is a very quick setup that we did here, but I would say this is a best practice. This is a best practice where now other people that work on my project at least know there's a basic level of quality. And also, I think it's very important for a portfolio project, and this will change the green in a little bit. It says that you care about doing things in a professional way. So I would say, this is really a fundamental component. Now, remember how I mentioned here that these cloud-based development environments, that there's a lot of them? We just did this one, right? We just did this one. But you can actually now take everything we did and we can do the same thing in, let's say, the cloud. And the cloud is a great place to do like high-level business analytics because there's so many powerful tools there. So let's do this next. Let's go to AWS here, and let's see how we could use this same repo that we just set up in GitHub. So what I'm going to do is I'm going to leave all this open, and I'm going to just open up AWS console. And you could use the free tier that would work very well with this. And we'll go to my account here. I'm going to go ahead and log in. I have two-factor auth here, so let me just type in a second authentication. And let's go to this. All right, and once I'm in here, there's really two ways to interact with like a Cloud Shell environment. There's, I would say, more of an advanced way, and then there's a more of a user-friendly way. Let me first show you the advanced way. Notice that there's this icon right here. It says Cloud Shell. All cloud environments have this. Let's go ahead and click it real quick. Now, the reason why this might be something to consider is that depending on what it is you're doing, there are some advantages to using the shell itself. One of the advantages is that every cloud environment comes pre-installed with their tools. So let's say you needed to copy some data from one location of Amazon S3 to another, like let's say a terabyte of data. You could do it via the Cloud Shell. You could basically make an API call that says copy the data from this bucket to another bucket. You could also interact with services. So you could interact with their machine learning products, SageMaker, and control it. You could invoke AWS Lambda functions via the AWS Cloud Shell. So you can, from a very high level, interact with services. And so without even needing to pay for it, the Cloud Shell environment is actually completely free. So there are some advantages to this. Now, the downside is that it kind of expect that you know Linux and Bash very well, and so that's why I'm going to just really briefly show this and not go into the details too much. But in a nutshell, what you'd want to do is you could do the same thing we were doing before with code spaces, but in this case, I'll manually clone this repo. So I'll click on code and then say copy, just like this, copy this, and then the thing to be aware of here is that if you've never set up a Cloud Shell environment, you need to create SSH keys. And so you would type in SSH hyphen keygen -t RSA, and then just run this, and then it'll go through and create. We don't want to overwrite it because I already have these, but you would do something like this so that you could communicate with GitHub. In my case, I've already got these, so all I need to do is just do this. I just need to say git clone like that. And then once I do git clone, because of that really clean structure that I set up, it's trivial to get my environment set up. All I got to do is I just say make all, right? And now let's see, why does this work? See this Makefile for this project? What does all do? It runs the installation, which installs my software. It runs a lint, which makes sure that my code works. And then it goes through and it does a test. So it basically just validates that, hey, everything should work. And if you use this structure, it's very clean to communicate with other teams. You just say, do a git clone, do a make all, right? Or, create a Python virtual environment, do a git clone, then do a make all. So if we go here and we say make all, what happens? Well, first we need to cd into that directory where the code lives, and then we do make all. And then this should install lint test, and then we know everything works. And that's, again, one of the really nice things about this cloud-based development environment is I could keep doing this. Like I could now go to another cloud environment and look, everything works, right? So this is really a clever way to set up your projects. And I think most data scientists don't do this, and they should, because it's going to save them a lot of time. Now, let me now show you the more user-friendly way. So again, because this is in a terminal, not everybody has a ton of experience with text-based editors like VI. So a more user-friendly way would be to go to something called Cloud9. And what Cloud9 is that it's very similar to Codespaces, which is, this Codespaces right where you have an editor and you can kind of interact, and it's a GUI, and it's very similar. So if we go to this cloud environment, we can say create a new environment, and we can call this data viz, and maybe just say this is for AWS data viz. We go to the next step here, and then notice that if you're a student, you can use all this stuff for free, right? You can actually, if you use the defaults here, you don't have to pay anything for these services, which is also great. And notice that it'll also automatically hibernate for you as well. So it'll kind of just save its work and then hibernate. So in my opinion, if you are using AWS to do things, this is probably one of the best environments to use. Is just leave the default setup, and it'll be totally free, and it's a great environment. Now notice that if you wanted to, you could actually pick very, very large instances if you needed to do some really computationally heavy tasks as well. But for this, what we're doing, this is totally fine. I'll say next step, create environment. And this will take maybe 30 seconds, and it looks very similar, right, to GitHub Codespaces. And then I can do the same thing that I did before, which is create a Python virtual environment, set up my SSH keys, git clone it, and then do a make all, and then everything should identically work. So then what's cool about this is we've now got our code to work in 3 different locations, and that's how portable our project is and how high quality it is and how easy it is to communicate this to future employers, right? If this is your portfolio project, or people on your team, or if you're at a company, if you use this kind of workflow, it just really eliminates a lot of the things that can go wrong with software engineering projects, data science projects, and ML ops projects. So this will take just a second. There we go. It looks like it's already waking up. Usually when you build a new environment, it's probably 30 seconds to a minute. And then it's there permanently now. Now this will never go away unless I delete it. And really the only thing I need to do to start with is, as I mentioned before, because this is a new environment, I should do SSH key gen so that I have some SSH keys. And notice that what happens here is that it puts a public file, and this is the file that you could put on the internet if you wanted to. It's all it does is uniquely identify the private key so that there's a link between these. And so if I go here and I copy this, I can go back to GitHub and go to my profile and go to settings, go to SSH and GPG keys, create a new key, paste this in, and we can call this AWS Cloud 9. Add it. It'll ask me to authenticate. I'll go ahead and authenticate. Okay, now that we've got this set up, I can go back here and create a Python virtual environment. There's usually 2 ways to create Python virtual environments, either the tool virtual environment, or you can use Python 3-env. This one expects us to do it this way. So I'm going to say Python 3-env tilde, and we'll just call this code or something like that. There we go. It creates this virtual environment. I'll source it like this, code bin activate. And then all I got to do is do a git clone, and we'll clone the repo that I was just working with, which is data viz. This one. Again, we just click on this. Very important to only pick the SSH version. We'll go ahead and copy that. There we go. And I'll say yes. I'll cd into data viz. And look, it's got the same thing as Codespaces, right? The same kind of a layout. I can look at files. I can edit them. It's got debuggers. Really, really powerful environment for working with AWS. And now I can do the same thing. I can just go here. I can say make all. And it should install my software. It should lint it, and it should test it, right? So again, my opinion, this is a very powerful way to work with code projects. And now let me show you, now that we kind of feel comfortable with this, that another thing that you can do is you can even start to play around with a little bit of data science now, because remember, inside of here, I told it to install Jupyter, right? So Jupyter also installs the command line version of Jupyter called IPython. If I type in IPython, there we go. I can just start playing around with IPython, start writing code, whatever it is I need to do. I can start to use that as a terminal. Now, sometimes people will also do things like, let's install Boto 3. So Boto 3 is the SDK for the Python SDK for AWS, and a lot of times data scientists will use this to copy data back and forth or interact with services. And so if I just type in make install here, I can actually interact here with AWS. Go IPython. Yeah, I could say import Boto 3. Wait a second. We should have done make install. Let's double check that it. Oh, I didn't save it. There we go. You see, you got to make sure that this is saved. Let's do one more make install. Okay, here we go. Now it's downloading Boto. And the reason why I'm going to use Boto is that I can use it to talk to different parts of AWS. Like, for example, where I'm storing all of my data that I'm going to use for data engineering. So if I go here and I say import Bodo3, like that, now it works. And I could say client is equal to Bodo3.client and say S3, like this. And then I can just say client dots, and it should auto-complete a bunch of different things that are available for me, which is really cool. And I can say, I think it's like list buckets. Yeah, list buckets. There you go. And it'll show me all the buckets I have on AWS. Or is it client or is it resource? Maybe it's resource. Let's try that. Anyway, or you know, I know what it is. It is client, but it's list buckets. There we go, list buckets. So again, depending on what it is you're doing on AWS, this is really, really helpful to see how quickly now I can start to interact as well. Now, we haven't really done anything yet that's data visualization. We have just really basically set up the structure. So let's actually get a little bit of structure set up here. Now notice that not only do you have GitHub, AWS, which we just did, GCP, Azure, which I'll show a little bit of this as well, but also you can think of cloud-based notebooks in here as well. So even, for example, Colab notebooks work very well in this world. And so now what I'm going to do is I'm going to show you how we can inject a Colab notebook into this project. So what I can do is I'm going to go to another tab here, and let's just go here and let's just type in Colab like this. And so if you go to colab.research.google, notice that it has direct integration with GitHub. So there's a bunch of different ways to interact with Colab. I think the best way initially would be just say new notebook. And when you first create a notebook, in my opinion, the best way to create the structure is this ingestion phase, exploratory data analysis phase, modeling phase, and conclusion. And this is a very important structure to communicate with business leaders, to create portfolio projects. So let's go ahead and do this. Let's create a data viz notebook, and we can just rename this like this. And what I would typically do to start with is I would go here and do something kind of similar to what we were just doing. So I can say, for example, ingest, and this is where I would keep all the ingestion data. And then I could create another one, and I could say two hashtags, say EDA. This is where I would store my exploratory data analysis. Create another one. This is where I would potentially create some models or do some kind of data science work. And then here, I would do another one and say conclusion, like this. And this would be the structure. And if you do it the way I've created this, one of the neat things is that it'll create a hierarchy. In fact, we can even we can move this up to the very top here. And one of the things that we can do is we can actually say, we can put one hashtag, so it'll be the very top of the hierarchy, and we can call this data visualization, or whatever it is my project is called. And then what's neat about this is, look, there we go. I can collapse all of them, and they're all underneath this target. And it really becomes helpful if you're dealing with very large data visualization projects or very large project. It's almost impossible in some cases, if you don't use something like this, to even know what's happening. And look at this. What's really neat is that you can also click on this table of contents, and look, it even shows you the table of contents. So you could also be sharing this with a coworker, someone on your project, or even walking through someone on an interview, and you say, look, here's my project. Here's the top of the hierarchy. Here's my ingestion phase. Here's my exploratory data analysis phase. Here's my modeling. Here's my conclusion. My opinion, because I grade a lot of data science students' projects, I tell them to do this. The difference between someone that uses this, some kind of a structure like this, or someone that just throws a bunch of stuff in a notebook, it's very different. I would say that it feels so much more professional when I'm dealing with a student who builds out a structure like this. So there's a hierarchy, and you can easily figure out where to go to. Now let's see how easy it is to now take this partial progress and check it into our initial structure we've already created. It's very easy. I just do this. I say File, and I say Save a Copy in GitHub, just like that. And in fact, let's even take a picture of this, right? I'm going to do a screenshot, and I'm going to take a picture of this, and I'll even add this inside. So we'll say Save a Copy in GitHub. It's going to say retry. And there we go. Look, it's going to call it this file. And it'll even include a link so that other people can open it in GitHub. And then what I can do is I can scroll down to the project that I want to check it into. We'll call this data viz right there. And I just say, okay. And what's great about this is that now it's in my project, right? And then if I want to have another person open it, they just click this button. There you go. And now they get the same project that I worked on. Now, we haven't put anything in there. I'll put some stuff in there in a second. But in my opinion, this is a very, very clever kind of workflow here. And in fact, if I go back to the data viz project here, you can see all the different assets I've got in my project. I've got, maybe a script file. I've got my requirements for my project. And then I also have a test script right here. Let's get inside of here and play around with how do I actually get something useful going quickly so that I impress the people at my work or whoever I'm on a team with. So how do we get started? We have this empty structure right here in this notebook. Well, a couple of things to consider is that for ingestion, I think it's a good idea to try to ingest resources that are available in a reproducible manner. And this is really easy to get yourself in trouble, is that I see this all the time in student projects is people will do this. They'll say, import pandas as PD, and then they'll say this. They'll say df equals read CSV, and then it'll be like C : data. This is a problem because this doesn't exist. Like, this exists on your computer, but this doesn't exist to the person that's trying to give you a job. And then they check out the project, and the first thing that happens is it fails, and then they say, yep, next, and they go to the next resume. So I think this is very important, is to think about this concept, and I'll put a note here that the ingestion should be 100% reproducible, right? So that if I'm going to give somebody a notebook, they should be able to do what I'm doing. This is not reproducible. So I'll put a comment here that says, not reproducible. Reproducible. Now, what is reproducible? Well, let's go to I think I have an example of this that has some good stuff in this minimal Python repo here. And I have a notebook that has some data science stuff in this particular project, and I'm going to open it up, and I'm going to just steal some ideas from here. So notice that if I go here, and I just copy this line of code and I put this into our project, let's close this, that I'll add another code block here. We'll do this. So we can see that this URL is actually something that if I just put it into a web browser, we can see it's just a straight CSV file. And this is, I would say, in a way, for a smaller size data science project, the dream scenario, especially for a portfolio project, because other people can reproduce what I did. And so again, if I go here and I just say this, and I click on this, this is 100% reproducible. And then if I go and I check this back in and I say save a copy in GitHub, then what's great about this is that other people can completely reproduce what I did. And so let's go down to data visualization. There we go. Check it in. And now I could even go back if I wanted to some other environment and check it out. But basically, we can take a look at it inside of this particular repo. And if I go to this DataViz notebook, there we go. Right, we can see it's reproducible. So I think very, very important to do this concept. And I mentioned this earlier. If you wanted to, you could even, depending on what kind of notebook it is, you could even execute these cells using the PyTest plugin to validate that. Like let's say, for example, that you worked on lots of different Jupyter notebooks. It's possible maybe certain parts of your pipeline you would want to test the notebooks and maybe just test like little snippets of different notebooks so that it would be easy to reproduce those notebooks and give them to other people. So there are some, I think, advantages to thinking about also maybe executing some of these cells automatically using the approach that we just went through. But in general, what's nice again about this is, look, I can just hide it as well, and I could just start to focus on, okay, I want to work on this project mostly in exploratory data analysis, and I'm gonna do describe, and I'm going to do some descriptive statistics and start to play around with things. I think I even have some visualizations here. Let's just copy here we go. Let's just copy this. And if I want to go into the visualization, I can just add another cell here and just throw this in. There we go. And I think that this, again, we can go and save a copy in GitHub. Go back to this and go to DataViz, clone it, and then we should be able to automatically refresh, and even the visualization should pop up in this notebook. So I think this is a great workflow. This is really the scaffolding structure that should work for most projects, is set up some automation, get this reproducible ingestion. And it really is, it seems simple, and it seems like, why is this such a big deal? Well, it's a big deal because if other students, other people on your team, other people in your company, other people looking at your portfolio can't 100% know that your code is good and that the data is good, I think it diminishes what you're giving them, right? Because again, if you imagine someone they say, hey, I created a really good, machine learning model, and then you check out that project and nothing works, all the code's broken. You then try to use their data and it says C data TXT. It's like, wait, what's going on here? Like, maybe it is good, but I can't prove what you're telling me is true because I have no idea if it works. And I think this is a critical component to initially starting a project. So once you've got this, this is where you'd start to keep going further and further and doing more and more things and playing around. And you, if you want to, sure, maybe create up even more structure. Like we have ingestion, exploratory data analysis. I mean, you could either, even maybe here, you could also put a section called maybe like data cleaning or scraping, right? Like, whatever it is you're trying to do for your particular project, there's no perfect right answer for it. But having the structure, I think, is really, really helpful. Now, let me talk about how we can use, other than just writing code, other techniques to rapidly get results. I think, many people are interested in not just knowing how to use Python to do data analysis and data science, business intelligence, but what if you just really don't want to write any code at all? Can you also do things to analyze data? Well, fortunately you can. And one of the ways you can do this is by using a cloud environment, and you could use any cloud environment. I'm going to start with AWS because they have the largest market share, but let's go to AWS here and let's see what kind of tools we could use to do things without writing any code at all. So one of the tools that we could use is the natural language processing tool. So if I go to comprehend here, for example, one of the neat things about it is that I can just click this button say launch comprehend, and I can start to just throw things inside of here and actually just use this as an initial way to prototype a result. So I think there was examples. Let's see here. I'm going to find the data storytelling repo that I had here earlier, which was data story. Yeah, this one. And notice that inside of here, we had, maybe it's not this one, it's the, let's just find Hemingway text. Hemingway text. And I believe you can just get his book, plain text. I think it's called like Gutenberg or something like this. Yeah, let's just grab this. Here we go. Here's some file. We can just grab this. I could just copy like from here, just kind of copy a bunch of this text, maybe a sample of it, or even this. We'll just copy a few of these things, and I go back to comprehend, and I could just analyze this, and I'm not writing any code at all. I'm just clicking this button, okay, and what it's going to do is it's going to extract all the entities from this chapter, and then if I wanted to, I could export this into a file and do things with it. I could look at key phrases. Here we go again. Here's all the different key phrases: horses, road. I can even see an application response. So I guess if I was lazy, I could even not write any code and just copy this. So I could even do this. I could just copy this and go back to my notebook and put a code cell in here and just throw this in. See that? It just creates like an API call, and I believe I could just say, even call it something. I could go here, scroll up here, and just turn it into Python. Just say var equals or something like that. Just make a variable, and then I could make another code cell, make this one above, and we could just say len var, and that would just show us that, yeah, it's got some stuff in there. Var type var, and we can see that it's a dict, and I could play around with it a little bit if I wanted to. var.keys, it's just got key phrases in there, so we could do this, make another code cell. You could start to do var key phrases like that, and then we could even grab let's see here, text like this, var key phrases dot keys. Oh, it's a list. So it's basically, we could grab one thing at a time, right? We could do something like this. Anyway, we could start to manipulate it with again writing very, very little bit of code by just using a tool, put it there, and then getting the key phrases out. So I think this is an approach that shouldn't be overlooked depending on what kind of problem you're solving. Like, why not? Why not just put it into a high-level tool like this, paste it, grab it, and then either maybe the text itself is totally fine and you're good with this, or you can even grab this and you could put it into a chart or take a picture. Like, you could even do this. You could just only get the sentiment and even take it. You could screenshot it, right? You could just say, here we go, here's my screenshot, and then you could go back to our GitHub project here, which is, let's just open up GitHub real quick, and let's go to data viz, And if we go to the issues, remember that we could store images inside of GitHub. I could just put another image in there, which is the screenshot. And I could, inside of here, just copy this. And then what's neat is that our notebook here, that if I want to, I could actually add maybe like a section called, GUI sentiment analysis like this, and then basically just paste that in. Look, there we go. Now we have like a sentiment analysis. So again, depending on what kind of problem I'm trying to solve and how quickly I want to solve it. Let's say you need to do something in 10 minutes. The GUI tools are pretty powerful for doing sentiment analysis, for doing natural language processing. And then again, I just go here, I say save in GitHub, and I can go to this repository here and just check it in. And we're just keep making progress very, very quickly. So we already got continuous integration. We got some notebooks working. We got some very basic visualization. If this stuff is too big here, like this data scraping is annoying, now I just close it, right? Like this was kind of hard to look at. It's like, oh, there's too much stuff. Just close it. Now I can focus on this, just GUI sentiment analysis. What if I want to do more than just sentiment analysis? I want to also use other AI tools to analyze things. Easy. Let's just make another cell. So we'll go here and we'll do this. We'll say GUI computer vision. So what we can do as well is create another cell here. So we can go to maybe a book called Old Man in the Sea. There we go. In the sea. And we can just take this cover of the book. Let's just take one of the images we find here, which is, I think this is the original one, was this. Yeah, let's take this one, Old Man in the Sea, and take this image, and I'm going to download this image here, and then I'm going to go to AWS again, and I'm going to use their GUI tool called Recognition, and I'm going to just throw this in there. So I'm going to say try demo, and then I can just literally click upload and go to downloads here and just throw this Old Man in the Sea. There we go. And now we're able to use these results. So it found that it was a novel. It has book, label, art. So it's able to find all this really cool stuff. And we can do, again, a couple different things. We can download the full list. So let's go ahead and download this. And then what I could do, if I want to be kind of lazy here, is that I could go back to this project and I could literally just upload these files into this project. So I could just go here, upload, and then I could just drag these things inside and just kind of drop different things inside of here. There we go. Classification labels. Great. Let's do this. Now look at this. This should be pretty easy. If I see classification labels, look, we see all the different labels that are available inside of this. And I think that these are all the things that it knows about. And so if I wanted to, I could, build more stuff with that, or I could also go and get the response right here. And I can do what I did before, is I could grab all this response. Let's kind of put this into text, go back again to this, and let's make a code cell. And we can say labels is equal to like that. And then we could do something similar, labels.keys. We can see it's got labels. So let's go here, labels. There we go. And it shows you all the different labels. And then again, you can iterate through whatever it is you wanted to do for this. And you could say, grab one of them out, right? So you can programmatically access it, right? That's one way to do it. Or you can do what I did before, which is, again, just go to this, take a picture, screenshot it, go here, take this, go back to our project, go to the issues, go into this, throw one in here. We'll go to the desktop. Here we go. Here's a screenshot. Upload it. And again, we can just easily put this inside, and we could even put a text block that says, 1, 2, 3, output of CV labeling. And then this would be actually a text field, so we'll get rid of this. And then this image that's hosted now comes in very handy, right? So I do think that this is an underutilized approach, is to rapidly prototype data visualization, especially with using off-the-shelf tools or using high-level computer vision tools, high-level NLP tools. And depending on, again, the analysis you're doing, it may not be worth writing a whole bunch of code. Maybe it is. It could be that you're building a whole pipeline and you want to do it very high quality. But in some cases, you can actually add a lot of value by just really quickly just cut and pasting, using tools, using the highest level approach you can to just start to build out a prototype. So then you can share this with other people. And then this could be maybe somebody on your team, right, where you're just sharing, hey, look, here's what I found. I took, like, for example, you could say, I took 1 hour and I used all the high level tools I could, and I discovered X, Y, and Z about this particular data set or these different data sets. And it does look like it's feasible for us to go deeper, right? That could be a great technique to use, again, to really rapidly build out some kind of a solution. So again, we go here, we say save a copy in GitHub, and we can just keep making progress. Now we have some computer vision in here, and we go through here and we go to our project here, which is data viz. There we go. And if I wanted to as well, I could even put this old man the sea picture in here. We could do all kinds of things. Let's see, it's under downloads. There we go. Throw him in there. And perfect. Go to chapter 7. Let's go to data viz here. Add another text box. In fact, we could even just add a section, maybe a little code block here, and just throw this at the beginning to just make it look better. Anyway, it's really up to your own creativity, like how you want to use a tool like this. I do like to do rapid prototyping of things, so that I can if I'm working with someone, show them very quickly how much progress I can make. So these are a few tools like Recognition and Comprehend that are available on AWS. Another one that's more holistic, that's a little bit like Tableau, is there's also a tool called QuickSight. So let's take a look at how that would work. And so with QuickSight, if you remember, I had that COVID data set that was stored in Amazon stored in GitHub. And one of the things that I can do is and this has a whole GUI that kind of walks us through how it works, is I can have AWS data, I can have files, or I can have apps. And so QuickSight does super fast calculation, and it does automated data exploration, even machine learning. And then I can share these things with other people. So if I want to create a new analysis, for example, I could say, here's a new data set. I could upload a CSV file. Now, what I could do first is, again, go to this data set, which I had accessed earlier. And let's go ahead and just get this link. And so I'm going to maybe just open this up like this. And then I'm going to save a copy of this. I'll say File, Save As, and I'll just put this under my desktop. And I believe that, yeah, that looks good. And then what I'm going to do is I'm going to say upload. and then we'll say US. Now I do want to, I'll have to label it or change the, let me just open up a terminal real quick here on my desktop. I need to change the file extension to CSV. So I'll just do that real quick. Okay, so it's a CSV file. Upload this. I should be able, there we go, US states. And now it's able to upload it. And so as long as it's in that kind of a format, CSV file format, it will automatically detect all the things for me. So again, I don't have to write any code here. It can figure out that this is date, this is a state, this is some kind of a code, and these are the different things that we need to do. I'll say next, and then it says visualize. And then once I click visualize, it'll automatically create this dashboard, which allows me to kind of play with different variables. So let's look at cases, and then let's look at deaths, right? So we have sum of deaths here, and then if we add cases here, right, we can have a very good visualization automatically. And then notice that this tool here, it says Autograph selects a visual type based on the number and types of fields. So what if we click on this? What happens, right, is that it automatically knows how to figure out how to do visualization. I just click the buttons, and it gives me a reasonable data visualization. So again, what we could do is let's export this, and let's just say save as, let's actually just do a screenshot again. Although, yeah, let's just do a screenshot. We'll go like this, and then I could just put this inside of my project here. So I would go to GitHub, go to my data viz, go to my images, and just throw this in there. There we go. There's a screenshot. Again, grab this. And maybe at this point, maybe I've already done a bunch of work and I already know like that we're ready for the conclusion. And maybe at this point, I'm just ready to put this out like, here is the COVID data and what we need to address. So again, depending on what kind of problem you're trying to solve and what you're doing with it, we put this in here. There we go. Now we've got a data visualization. Now the other thing that you can do with this kind of stuff as well is that you can share this. Like if I said publish dashboard, you could make a new dashboard. You also can share this with people via email, and then these could be people in your company or whatever. But yeah, in a nutshell, there's also insights here. So you could, look at different things like, I don't know, like show me some insights into some particular different thing. Show me the, let's add a dimension here. Let's add cases and states. Right. So a lot of this stuff is something where you can tell it that you wanted to visualize things by just experimenting with the data without writing any code. And so I think this is probably one of the more useful things to consider when you're initially prototyping things, is that yes, you can absolutely go back to here, right, and you can build stuff yourself, right, by doing to exploratory data analysis, doing plots. But in many cases, especially if speed is something that your organization wants to adopt and you want to kind of go through really quickly and get results, is use the highest level tools you possibly can. In some cases, it means not writing any code at all, like in this particular case down here, right, where we just uploaded a CSV, click some buttons, it visualizes it, and then I can immediately start doing something with it. And in many cases as well, with a tool like QuickSight, it can also automatically do clustering. It can do automatic predictions. So I think in the world that we're headed towards with data visualization and data science, business analytics, is the higher level tools, the better initially, so that you initially build something out quickly, show results, figure out if something's feasible. You can always do something manually later. You can always make something more complex. It's much harder to initially build something quickly to figure out the feasibility of a problem. And that's where, using these high level tools for data visualization, I think are so important because of the rapid feedback loop.